Okay, so we'll get into the distance from a point to a plane section here. So here's a practical application. So you're dealing with a problem here. They describe it, yeah. So you're an engineer consultant. You are to supervise an urgent upgrade, yeah, on a high security radar unit, and that unit is at a remote mountain location. And there's a rotating detector antenna. Your antenna unit requires additional support in order for for it to be stabilized. Yeah, so this engineer needs to stabilize. Engineer is you, of course. You gotta stabilize this antenna. Yeah, and that's a sensitive instrument, so it must be attached to the top plane. All right, of an underground deck plate. So you've got a deck plate, so that's your plane, and it's got to be attached to the top plane, top. All right, so that's your view, routed to a prescribed location on the central support column. So because of its remote location, the required scanning spectrum, the deck plate is oblique, it's set so, your geometry to all sides of the superstructure, which conceals it. So meaning you can't really determine, right, the obliqueness, how they are aligned, or how they're positioning, right, in these planes. So under your supervision, test holes have been drilled, and you have established the location of the top of the deck plate as shown at points 1, 2, 3 on the next slide. Okay, we'll get into the diagram, so don't worry about it. So your assignment, so what are you going to do? So assignment is to gather the following additional information. So the very first one you have to do is ascertain, okay, the slope angle. Ascertain is just determine your slope angle of your super plane, right? Surface plane of the deck plate, and then the second, determine the exact length of each support member. Yeah, that's going to be required for your horizontal, vertical, and then your perpendicular position. So spanning the distance from the anchor position on the support column, point A, that's on your support column, to the top of the deck plate. So this is pretty long problem, so don't worry about it. Every time you get a very long problem, you're gonna make sure you got the planes, because you gotta identify which are the planes, what are the views, and how many points you've got on these planes. Okay, all other things, who cares? So you can pinpoint all of that you need, okay, like this. So right now I'm just gonna, I know that there are 3 points, I know that I'm dealing with oblique, okay, kind of, because it's set so, and I have a dead plate, okay, so, and it's set so right there. So this is how you scan the key points, of your problem. And then I am looking for my slope angle, surface plane. That's set it, so surface plane of the deck plate, okay? And then we have our horizontal, vertical, perpendicular position, So these are the things that we wanna, okay? And that point A, to the top of the deck plate. Another position on the support column is your point A, okay? So that's how you scan your problem, okay? You should be able to do it as quickly as you can, of course very carefully, but quickly, okay? Scanning the key points. Now we're gonna get into that. I know that I have 3 points, I'm dealing with the top, right? I'm dealing with the top, right, surface. So here we're going to start with surface, and there are 3 points on it. So that's what we start doing it. And it said these points are coming out from the drilling. So 3 test holes have been drilled to determine the location on your top surface. It's the first information you get out of all that. Okay, because it said it so here, top. 1, 2, 3. Okay, and see, it's been drilled. So that's how you spot your problem, Then it's at the point A, the support column. Point A is your anchor point on the superstructure of your radar unit that you're putting up, on that deck. So here is your horizontal view, and then we're gonna have a point A as a support anchor. Then from the top view, we gotta get our front view, all right? So your orientation, your depth, and the location of the drill, right? We will label that 1, 1, and then 3, 3, and then 2, 2, and then AA. Okay, don't forget your full line is right in there, in between them, in between the two views. And of course, your A is your anchor point, your support. Okay, so we got all of the relative locations right in there. So that is how we handle, okay, points problems. So distance from a point to a plane. Okay, so here are the distance, your horizontal view, and then your frontal view. Yeah, and these distances got to be relative to each other. Yeah, okay, get that. And the only thing that difference, I don't know if you can be able to see is this guy, and that is different. It's because of your views are different. Okay, your plane is different. That's looking down, right, the top view, and this is looking towards it. Okay, so your this A is right there, and then of course your 3 and then 1, 2. Yeah, and I don't have to draw this full line here. Okay, straight. Just suppose this is straight line. Okay, so this is proportionally. Remember your extension, your lines right there. Yeah, you extend right here, here, here. So that's your projectors. Yeah, corresponding to each other. The only thing is this guy. Okay, that's just when you flip your top view to the front like that. Yeah. So please practice.